And now we're going to graph from factored form. All right, so factored form tells us some important information about the graph. It is really helpful in identifying the x-intercepts. All right, so again, not every quadratic can be written in factored form because not every quadratic has x-intercepts. Okay, but when it can and when p and q are integers, okay, it's really easy to find. Okay, so we have f of x equals negative times x minus 2 times x minus 4. So right away, I know this graph is going to be going upside down. The parabola is going to be reflected, okay, because the a is negative, so it's going to be reflected over the x-axis. All right, and I don't know my vertex, but I do know my x-intercepts. Okay, my x-intercepts are what make each factor equal to 0. So what makes x minus 2 equal to 0? And that's 2. So one x-intercept is 2. So we write that as an ordered pair, 2 comma 0. And then the other one, what makes the other factors 0 would be positive 4, because 4 minus 4 is 0. So 4, 0. So my two x-intercepts are at 2 and 4. All right, and so those are two very important pieces to our math here. Again, that's called the zero product property, okay, because anything times 0 is 0. So if one factor is 0, then the whole thing is 0. So that's why we focus on one factor at a time. All right, and so now, since we know parabolas are symmetrical, all right, that means that the vertex has to be the midpoint between the x-intercepts. Well, this one's pretty obvious here. What's halfway between 2 and 4? And that's 3. So my vertex is going to be at 3 something. We could back into it using our pattern of 1, 3, 5. Since that's only 1 away, we know it's just going to be up 1. But we could also plug in 3 here, all right, and find out our vertex. So if I plug in 3, all right, so 3 minus 2 would be 1. And then 3 minus 4 would be negative 1. And if you multiply that with a negative out in front, you get negative 1 times negative 1, which is positive 1. So our vertex is 3, 1, which confirms with the pattern of 1, 3, 5. And so I really already have enough points to graph here, but I could continue to go over 1, down 3, right, over 1, down 5. And I could continue to follow the pattern if I wanted to, but really, 3 points is enough to kind of sketch the graph. The more points you have, the more accurate your graph will be. Right? And at this point, now that we've seen a lot, I don't think we need to plug into the table of values. I believe that the pattern has been verified and will always work. Okay, again, this one's going down 1, down 3, down 5, because the a is negative 1. All right, so let's go ahead and try one more of these. So now we have x plus 2 times x minus 4. Okay, a is 1. All right, so this one will be probably going up. My x-intercepts are going to be what makes each of these factors equal to 0. So what makes x plus 2 equal to 0? That's negative 2. So this x-intercept will be negative 2, 0. And then the other one, what makes x minus 4 equal to 0? And that's positive 4. So now my x-intercepts are at negative 2, 0 and 4, 0. So now halfway between negative 2 and 4, all right, is 1. So 3 to the right, 3 to the left, that puts me at 1. You could also just do the midpoint formula, add up your x's, divide by 2. All right, so it's another way to get to the midpoint. So my vertex, okay, will be 1 comma something. What is that something? I plug in 1 into my x's, and I get 3 times negative 3, which is negative 9. So my vertex is 1, negative 9. So all the way down here. Okay, and so at this point, right, I can just sketch my graph since I have enough points, or I could use my pattern over 1, up 1, over 1, up 3. All right, finish plotting those out. And we have our parabola. And we could even check to make sure that we went over 1, up 5, 1, 2, 3, 4, 5. So that pattern did work. All right, and so we have our graph. We know our vertex, which was 1, -9. All right.